Hey, welcome back everybody. This lesson is going to cover writing equations for proportional relationships, 7.RP.2.c. What we're going to do is, like, given a proportional relationship, that's going to be a given. What you want to be able to do is you want to be able to take that proportional relationship and turn it into an XY equation, that states the proportional relationship. So let's go ahead and get started here. In our first example right here, we've got Krista has written her own recipe for pot roast. There is a proportional relationship between the weight in pounds of the pot roast, which represents X, and the total cooking time in hours, which is represented by Y. We want to take her recipe for 1A, it says. For 1A, it says her recipe mentions that a 4-pound roast should take 1 hour to cook. Write an equation. That's going to be our goal here today with this lesson, is to write an equation for the relationship between X and Y. Okay, you might have learned in a previous lesson that a proportional relationship between X and Y could be modeled by the following. You might have seen this: Y equals Kx, where K is the constant. All right, but what we're going to be doing is we're going to be writing equations out so that it basically looks like that. It looks like this, but it's going to be in this form where it's just going to be like Y equals 2x, where we have a number there. Instead of the K, we put a value there. There's a coefficient. Or Y equals 3/4 x, or Y equals, could be a decimal, 0.25x, something like that. It could be a lot of different things. Now, Y equals Kx is a fine way to express the proportional relationship in equation form. However, a lot of times we're looking for K. K is the part that we need. We're looking to find what K is, and then K is for the constant. Obviously, constant does begin with the letter K, but that's what it stands for. It represents the constant. So an easier way to kind of figure out what K is just to go back to this, to go back to the ratio form of what K equals. So Y over X, the ratio of Y to X, is equal to K. So you could just divide that. You could take the Y and you can divide that by the X, and you're going to get the K. Sometimes it'll be a decimal, or it could be written as a fraction, because either way is fine, or it comes out as a whole number. So really that's, I would say, this equation right here, Y over X, Y divided by X equals K, is a great way to kind of figure out what the K value is. Because like I said, a lot of times we're looking for the constant. We don't know what that is. And by the way, in this equation, K is the constant ratio of Y to X, and that's called, just so you know, that's called the constant of proportionality. K is for the constant of proportionality. Now, before we start inserting values into the Y and to the X, it's good to know what everything is. So let's figure out what X is. Let's figure out what our Y is. It says right here that for 1A, her recipe mentions that a 4-pound roast should take just 1 hour to cook. So we want to write an equation based on that. If we're doing this, our X, according to this, is the weight of the pot roast. So the pot roast is going to be 4 pounds. And our Y is going to represent the time in hours. And this right here, it says 1 hour. So that's how we're going to figure out. So if we want to know what K equals, we're going to take the Y value, which is 1, and we're going to divide that by the X value, which is 4. Now we could just very well leave it that way, 1/4, because that's in lowest terms actually. It's totally acceptable to leave it that way. Or you can just divide it, with your calculator, or just knowing that 1/4 is 25/100. Either one of these values for K would be acceptable. So when you write your equation out, let's kind of do this. When you write out your equation, we're going to write it out in Y equals Kx form, right? We're going to write it in that form, except we're not going to put the K, literally the K value in. We're going to replace the K with a value that we know it equals. So Y equals 1/4 x, that was one acceptable answer. Or, because both of these are equivalent, Y equals 0.25 x. Either answer would be perfectly fine. But those are your equations. That's your end game here. You want to get your equation. So y equals 1/4 x, or y equals 0.25x. And then knowing that, it's going to help you answer these follow-up questions, which are right here. Same example here. For example 1, we're talking about the pot roast. But for 1b, it says based on the equation, based on the relationship, the proportional relationship that we got for Krista, for her pot roast recipe, this question is asking how many hours will it take to cook a 10-pound pot roast? So how many hours will it take? All right, so let's make sure we understand. So x, what does x represent? Well, x represents the weight, right? That represents the pounds, right? And then y represents the time in hours. So when we set this up, it doesn't matter which one you use, 0.25x, y equals 0.25x, or y equals 1/4 x. Doesn't matter what you use, but we want to be able to put those numbers in there. So for this particular one, we know that the pot roast for that particular question is 10 pounds. So 10 pounds represents the weight. So we're going to put 10 pounds, we're going to put that number 10 in for x. Now it doesn't matter, I'm going to show you both ways. But if we do this, now 0.25x means 0.25 times 10. And then when you guys solve that, you're going to get 2.5. So that's 2.5 hours. 2.5 hours, and it doesn't matter which way you do it. We could do 1/4 times 10. If we just do that, so y equals, and we just multiply left to right, 1 times 10 is 10, and 4 times 1 is 4, and then 10 doesn't divide by 4 nicely, but we can reduce it by 2, and we get 5/2. And 5/2, if you change that to a mixed number, you get 2.5. So either answer is perfectly acceptable. 2.5 hours or 2.5 hours are both perfectly fine. Or if you want to write 2 hours and 30 minutes, right? You can do either one. That's perfectly fine. All right, in this example right here, we're still on the pot roast recipe question. This one's now asking us, based on the equation of Krista's proportional relationship, how many pounds does a pot roast weigh that takes 5 hours to cook? So again, it doesn't hurt to write this stuff down. But remember, x represents the weight and y represents the time, right? How many hours it's going to take. So this time we have 5 hours. We're looking for 5 hours. So where are we going to put 5 hours? We're going to put 5 in for y. So we're going to put a 5 in. Now both of these expressions, both these equations, both of those equations are equivalent, right? They're equal. So we're going to put 5 in there and we're going to solve it. So we got 5 equals 0.25x. Now that's more like a traditional equation that you have to solve. So how would you solve that equation? All right, well, you would take the number that's next to x, right? The coefficient that's next to x, and we're going to divide both sides by 0.25. Now these cancel each other out. They divide and they cancel each other out, turn into 1, essentially. All you're left with is x, or 1x. I'm just going to write x, though. And then we have 5 divided by 0.25. Now that's where you can get out your calculator and just do 5 divided by 0.25, top, divided by the bottom, and you should get 20. That's pretty big. So you're going to get 20 pounds either way. You can do this one the same way, too. So y equals 1/4 x, and then you can solve that by multiplying both sides by 4, or 4 over 1 if you want to think of it like that, because it's a reciprocal of 1/4. That all cancels out, and you're left with x there. And then 4 times 5 is 20. So you can tell we're dealing with equivalent equations there because we got the same answer. If we didn't have equivalent equations, we would be getting totally different answers. But since I'm dealing with equations that equal one another, they represent the same thing, essentially, then you should get the same answer, no matter how you do it. Now here's a different question. This is example 2. This one's talking about woodworking. This one says, Jordan enjoys working in the woodworking shed. Her favorite project is to build a cedar porch swing. There is a proportional relationship between the time in days Jordan spends making porch swings, x, and the number of swings she builds. We want to figure out what the equation is going to be for this proportional relationship. Now, it states in the problem that it's proportional. So the problem here is not determining whether it's proportional because we already know that it's proportional. The exercise here is to figure out what's the equation going to look like. Again, when we set up our equation, we want it to look like this, y equals kx, right? And then we want to put a different value in for k when we write it all out. We want to put in like y equals 7x or y equals 1/2 x, y equals 90x, whatever it is. But we need to figure out that constant of proportionality. So remember, to figure out the constant of proportionality is really easy. Just take the y value and divide it by the x. Take the y and divide it by the x. That will be the constant of proportionality. Now in this particular problem, the y represents swings, and the x represents days. So the y represents swings and the x represents days. So when we do this, let's look at the information. It says it takes Jordan 5 days, that's important, to build 2 swings, and that's also important. 5 days to build 2 swings. So we want to figure out, we want to put swings on top, so we're going to do 2, and we're going to divide that by 5. And I know that doesn't seem very natural. Usually you divide a bigger number by a smaller number, but probably at this point in 7th grade, you know that's not how division always works. We can divide anything by anything, as long as you're not dividing by 0. But if you use your calculator, when you do 2 divided by 5, you should get 4/10, 0.4. Or you can just leave it, you actually could leave it this way too. So 0.4 k, or you can leave it as 2/5 k, because 2/5 doesn't actually reduce. So there's your equation. Y equals 2/5 x, right? That's one of them. That's one of the possible equations. You don't have to write both of them every time. I'm just showing you both because it's just good to know. So you got y equals 0.4x. So both of those equations represent the same exact thing. Don't get thrown off by them. But that's what you have. So remember, that's our k value. But we don't have the k in there. We didn't write the letter k. We wrote down what the k represents. Now a follow-up question to the first one here, which is, we have our equations now. Those are our proportional equations. They both represent the same exact thing. One of them is represented using a decimal, and the other one we're using a fraction. The follow-up is, at this rate, how many swings can Jordan build in 10 days? So 10 days is the number. You want to figure out what that 10 days, where does that go in that equation? Is that our x or is that our y? Well, let's figure out this. Let's figure out what our x and our y is. So our x is what? Well, it says there's a proportional relationship between the time in days Jordan spends making the porch swings. So x represents days, right? That represents a time value. And the y represents swings. So where should we put 10? Is 10 going to be the y or is 10 going to be the x? Since days represents x, we're going to put in 10 for x. So we're going to solve this. 0.4 times 10. There you go. And then just, use your calculator, just write out the math here. 0.4 times 10 is going to be 4 swings. And it doesn't matter how you do it. We could put the number 10 in that x and we should get the same exact thing. So y equals 2/5 times 10 over 1. And then if we cross cancel, the 5 and the 10 turn into 1 and 2. 2 times 2 is 4. 1 times 1 is 1. And 4 over 1 still equals 4. So as you can see, we get 4 swings either way we do it. So that's great confirmation that we know that we're using the same equation, even though they look different. These equations are exactly the same. And then for our last example here, what we're going to do is we're going to figure out how long does it take to build 6 swings. So before we were looking for how many swings she could build. This time around, we're going to look for how many days does it take to build a certain number of swings. So again, it's good to know, you don't have to write this every time, but it's good to know what your x and your y represent. And your x represents your days, right? And your y represents your swings. Okay, so at this rate, how long does it take Jordan to build 6 swings? So the question here is, where do we put 6, right? Where does that 6 go? Is our 6 a y value or is it an x value? Well, It says 6 swings. It literally says that in the problem, 6 swings, so that's got to be our y. So we're going to put 6 here. And it's going to look more like a typical equation. So 6 equals 0.4x, right? And how do we solve that equation? So we're going to solve that equation by dividing both sides by the number that's next to the x. So 0.4. Now these 0.4s right here, they cancel. And now it's just a matter of just doing 6 divided by 0.4. So if you did everything correctly, you should have ended up with 15 equals x, or x equals 15. And then just to kind of stay true to what we have been doing, let's put in, for this one, let's put in 6 for the y here and just see how everything pans out. I'm going to set it up like this. 2/5 x equals 6. And when you solve that, the thing I always teach my students is to flip the fraction. Whenever there's a fraction next to a letter, flip the fraction, which is called the reciprocal, and then multiply that to both sides. Now this all cancels out. Those all turn into 1s, and you're left with 1x, which is just x, right? And then on this side, we can cross cancel. The 2 and 6 can divide by 2. And then 3 times 5 is 15. And then 1 times 1 is, if you put a 1 there, it's 1, but yeah, 15. So there you go. You got 15 days. So as you can see, it takes a little while to build these things. But yeah, 15 days, is our answer. Okay, so that does it for this lesson. Make sure you do the practice problems that accompany this lesson, and that should do it. Okay? Everyone have a great day. See you later.